Hey everyone, and welcome to this explainer on the absolutely incredible journey of air and blood inside your body. Today, we're really going to pop the hood and uncover the mysteries of your biological engine. We'll be looking directly at the science of how we stay alive, exploring the human respiratory and circulatory systems. So let's just jump right in and uncover how this all works together.
Listen, I want you to do something with me right now. Take a real deep breath in and let it out. When you do that, it feels totally simple, right? Second nature. But let's actually discover the invisible high-speed relay race that is happening inside you at this very moment. That single simple breath kicks off a massive logistical operation that travels from your nose all the way down to the microscopic cells in your toes.
So here's our roadmap for today's journey. We'll be hitting 1. The path of air, 2. Breathing versus respiration, 3. Inside the human heart, 4. The blood vessel network, 5. The composition of blood, and finally 6. Why transport systems matter.
Okay, starting off with Section 1, the path of air.
The path of air is a highly organized route. It kicks off at your nose or mouth, and from there, the air shoots down the trachea, which is basically your windpipe. Now, think of the trachea like a main, wide highway. But as we know, a highway has to eventually branch out to reach local neighborhoods, right? That's exactly what happens next. The trachea splits into smaller tubes called bronchi, which lead directly into your lungs. And these bronchi, they just keep branching out further and further until they end at the alveoli. These alveoli are absolutely fascinating. They're basically like tiny microscopic balloons. And this right here is the exact location where the gas exchange magic happens. The oxygen you just breathed in passes right through the walls of these tiny air sacs to enter your bloodstream, while carbon dioxide is pulled out so you can exhale it.
Moving on to Section 2, breathing versus respiration. It's actually incredibly common for people to mix these two terms up, using them like they mean the exact same thing. But in science, they represent very different processes.
So the crucial takeaway here is that breathing is simply the physical, mechanical pumping of air in and out of your lungs. It completely relies on the movement of a large muscle called the diaphragm to just mechanically pull air into the body and push it out. Respiration, on the other hand, is a cellular chemical process. It's the actual manufacturing of energy. Once that oxygen is delivered to your cells, it gets combined with glucose, which of course comes from the food you eat, to create the vital energy your body needs to survive. So think of it this way. Breathing is the delivery truck, but respiration, that's the factory.
And this brings us to a brilliantly designed system, the body's built-in backup generator. Usually, your cells use aerobic respiration. That uses the oxygen you breathe to efficiently pump out energy, with water and carbon dioxide just left over as harmless byproducts. But what happens if you're doing, say, high-intensity interval training or sprinting for the bus and you simply run low on oxygen? Well, your body switches gears to anaerobic respiration. It actually continues to produce energy without oxygen to keep you moving. Pretty amazing, right? However, the byproduct of this emergency process is lactic acid. And that buildup of lactic acid, that is exactly what makes your muscles feel so incredibly tired and heavy after a hard workout.
All right, Section 3, inside the human heart. Because now that we've successfully brought oxygen into the body, we need a seriously powerful engine to pump it all around.
Your heart is, without a doubt, the ultimate pump and a total marvel of biological engineering. It's neatly divided into 4 distinct chambers: the right atrium, the right ventricle, the left atrium, and the left ventricle. Think of the atria as the receiving rooms for blood coming into the heart, and the ventricles as the powerful shipping rooms that aggressively push blood back out. And separating these chambers are vital one-way valves. These valves act exactly like security gates. They snap shut the second blood passes through to ensure that your blood always flows in the correct direction and never flows backward.
Now, this constant rhythmic pumping of the heart is known as the cardiac cycle, and it's made up of 2 distinct phases. You've actually probably heard these terms if you've ever had your blood pressure taken. First up is systole. This is the active phase when the heart forcefully contracts, squeezing the muscle to pump blood out to the lungs and the rest of the body. Then comes diastole, the brief, crucial moment of relaxation when the heart muscle expands, allowing those chambers to refill with a fresh supply of blood. Contract, relax, systole, diastole. It's this relentless rhythm that keeps us alive every single second of every single day.
Which leads us perfectly into Section 4, the blood vessel network. Leaving the heart, this life-saving cargo of oxygenated blood desperately needs a route to travel on.
Now, not all blood vessels are created equal.
We essentially have three main types. Arteries are your high-speed outbound lanes. They carry high-pressure blood away from the heart, which is exactly why their walls need to be incredibly thick and muscular. Then we have veins, taking the blood back towards the heart. Because the pressure is lower on this return trip, veins have thinner walls, but they contain those clever one-way valves we talked about to prevent the blood from pooling down in your legs due to gravity. Finally, we have capillaries. These are the microscopic side streets connecting the arteries to the veins. They are literally only one cell thick. To put this crazy network into perspective, if you laid all the blood vessels in an average adult end-to-end, they would wrap around the Earth more than twice. No way, right? But that extreme network is absolutely necessary, because the actual exchange of gases, nutrients, and waste between your blood and your cells happens right through the extremely thin walls of those capillaries.
Moving to Section 5, the composition of blood. We know the routes, but what exactly is traveling down these microscopic highways?
When you look at blood, it honestly just looks like a uniform red liquid, but it is actually a bustling, multi-talented team working together. First, you have plasma. That's the yellowish liquid acting as the carrier, floating everything along the vessel network. Suspended inside that plasma are your red blood cells. They are the haulers that contain a highly specialized protein called hemoglobin, which literally grabs onto the oxygen in your lungs and carries it out to your tissues. Then you've got your white blood cells, which have a completely different job. They act as your body's frontline immune defenders, pumping out antibodies to fight off sickness and pathogens. And finally, the platelets. These guys are the body's emergency repair crew. If you get a cut, platelets rush to the scene and clump together to form a blood clot, stopping the bleeding and, quite frankly, saving your life.
And finally, Section 6, why transport systems matter. Let's just zoom out for a second and look at the big picture. Why is this elaborate setup of lungs, hearts, tubes, and cells absolutely essential for complex living organisms like us?
Well, think about it. A tiny single-celled organism can just absorb what it needs directly from its immediate environment. Easy. But you are made of trillions of cells. Without this integrated high-speed network of lungs, heart, and vessels, our bodies simply couldn't sustain life. This complex transport system is the only thing that allows us to efficiently transfer solids, liquids, and gases across vast cellular distances. It delivers vital nutrients to our organs, it constantly removes harmful waste products before they become toxic, and it even regulates our body heat by moving warm blood around our extremities. It is, top to bottom, the ultimate logistical masterclass.
So we followed the path of air, the mechanics of the heart, the specialized vessels, and the incredibly complex components of blood itself. Knowing this non-stop journey happens inside you every single second without you ever having to even think about it, how are you going to fuel your engine today? With tens of thousands of miles of microscopic highways keeping you alive right now, what choices will you make to keep your transport system running smoothly? Thanks so much for joining this explainer. Take care of that incredible engine of yours.